咱们小李，咱们那个秘书教学的这个在会上能听见我说话吗？能看见 PPT 吗？
啊，老师能听见 PPT 可以看见
都可以看见是吧？
啊。
好，哎，那我就把头像关掉，然后啊。Hello, everyone. Can you hear me? Are you found the PPT?
Yes, we can hear you and we can also see the PPT.
You cannot find the PPT?
Oh, Lucy, we can find.
Professor. Yes,
Fine,
I see your PPT.
Oh, okay.
刘老师，那个 PPT 可能您需要幻灯片放映一下，它
我还没到放映的时候，对，现在你看可以了吗？现在可以是吧？
啊，刘老师现在可以了，现在是全屏了。
Everyone, please turn off your audio, please. If you have a question, please turn on your audio, please. Okay, time is for class. At first, thank you all very much for choosing our laboratory element science. At first, let me introduce myself first. My name is N.Qi Liu. I'm from Laboratory Element Center, Xi'an University. Our Element Center is also the Department of Laboratory Animal Science, School of the Basic Medical School of Xi'an University. You can find my email address liu.n.qi and @mail Xi'an University. You can easily find my email address. My cell number is 1-886-818-7749469. If you I am in charge of this class. If you have some suggestion, if you have some question, you can call me. You can send an email to me. I'm sorry, because of the epidemic COVID-19, I am at home. Our campus of university is closed. I also cannot enter campus. I think maybe you are all in your country. So because academic, you cannot come to our campus to study. So we have to use the online teacher. This is schedule of our course of laboratory animal science. As shown this slide, the course study from 2 p.m. to 6 p.m. every Tuesday, Beijing time. There are total about 14 hours of laboratory animal science. Six time is a theory, and 4 time is animal experimentation, and 1 is visiting our laboratory animal facility at 3 of the basic experimental technician in mouse, rat, rabbit, and transgenic technique show with you. So this is a total schedule you can find from this slide. My name, first time today, I will introduce introduction of laboratory animal science. The second, Dr. Wang Weirong will introduce autonomy, physiology, and husbandry of common animal laboratory animals. The third, Dr. Wang Rong will introduce the quality control of laboratory animal science. Dr. Bai Liang will introduce genetically modifying animal generation, how to creation and application in biomedical research. Dr. Zhao Sihai will introduce the animal models and animal experimentation, how to design an animal study, how to perform the animal study. The last one is about the management and welfare of laboratory animal. We will invite a scientist from Japan. Dr. Jiang Lingfei will introduce animal welfare and management of the laboratory animal study administration. This is all schedule of by our laboratory animal science. This slide shows some of the reference, some textbook for our class. The first is a Chinese version. If you understand Chinese, you can find this book is also interesting. This book edited by me. So I writing this book. The English name is Medical Laboratory Animal Science. The second is animal models, human disease of animal models, also edited by me. So I write the second Chinese textbook. The last one is the fundamental of the laboratory animal science. The published by CRC Press. CRC Press is a very famous press in the world. So I teach some foreign students about laboratory animal science. I don't find it very good in the textbook. So Dr. Fan with me, we write the fundamentals of laboratory animal science. If you're interested in our course of laboratory laboratory animal science, you can reference the 3 textbook about our laboratory animal science. If you don't want to buy this book, you can send me an email. I can send you some copy of the textbook for you. This is about the reference of our laboratory animal science. Today I will introduce about the something of laboratory animal in biomedical research. The first I will introduce how to perform the biomedical research. The second I will introduce why animal need in biomedical research. The third, I will introduce what kind of animal used in biomedical research. For example, mouse, rat, guinea pigs, hamster, and other animals were used in biomedical research. I will introduce simply about the character of these animals. The fourth, I will introduce the standardization of laboratory animals and genetic environment, facility, the nutrition, standardization. The fourth, I will introduce about the instincts in animal experimentation. There is something animal study that involve instincts involve the animal welfare. I will introduce some information about the animal study, because some people they are against animal studies. They oppose the animal study in biomedicine. So there is some issues about instincts in animal studies. Last one, I will introduce the laboratory animal management or the administration animal study. So this is the content of today's lecture. At first, I will discuss with you how to perform, how to do a biomedical research. The biomedical research is the same as other studies. And first, we have to propose a hypothesis. If we have a hypothesis, there are two kinds of the biomedical research. The first one, the observational study. The second is experimental study. So when we have the hypothesis, we have to do observational study on experimental study. When we finish the study, we have a result. We have the data from this kind of study. The data, what use of this data? The first, for most students and most of teacher, the data will be publication. We submit our manuscript to a journal, for example, to the journal, then our result will publication. For most students, most teacher, the result from our biomedical study, the result will be submitted to a journal and a publication. The second, for the medical research factory, for example, pharmacy factory, they will apply a patent. Patent is very important for medicine. So, and I think the final mission of the biomedical research is a translation. Translation means the basic research result will be applied in clinic study. This means translational study. So translational research, translational medicine means from bench to bedside. Bench means basic research. Bedside means clinic study. So this is, I think, the final mission of the biomedical study. So the result of biomedical study will be applied in clinic study. This means translational research. At first, I will introduce I just show you there are two type of the biomedical study. The first one is observational study. The second is experimentation study. So at sure I will introduce something about observational study. Observational study is a type of study in which individuals are observed or certain outcomes are measured. Not attempt is made to affect the outcomes. Mean, for example, no treatment is given. We found that something happened, but we don't affect the process of the study. This means observational study. So the research sample observes the behavior in a systematic manner without interfering with the behaviors. This kind of study we call observational study. The sample scene means just looking what happened, but we do not do something for this study. This means observational study. There are 5 types of observational study. The first is case control study. Case control study in Chinese we can call the 病例对照研究. That means this is a retrospective study. This is a very most popular study of the observational study. Study originally developed in epidemiology, in which 2 exciting groups, for example, one group smoking, another group no smoking, so different group. Different in outcomes are identified and compared on the basis of some supposed causing contributing. This is a control. This is a case control study, the most popular study of the observational study. The second we call the cross-section study. The third, the longitudinal study. The fourth is the cohort study or panel study. The last one, ecological study. This is the 5 types of the observation study. The first type is very famous. And the most popular study of the observation study. For example, I will introduce of the observation study for you. For example, the World Health Organization, we know WHO performed the observation study and found cardiovascular disease mobility is a mobility rate is about 30% of the global deaths. Global deaths is the first one. Killer global disease is cardiovascular disease. We call CVD. There are about 20 million people dying from the CVD every year. I calculated from 1 million. There are about 38 people dying from the CVD. This afternoon we study here. We study here about 2 to 4 hours. There are about 9,000 people dying from CVD, cardiovascular disease. So we call cardiovascular disease the first killer in the world, because most people dying from CVD in the world. The second mortality is cancer. Around 13 people died from cancer. This is the second. In the world, about 55 million died from different disease every year. So this slide shows a very important disease for human being. The first is cardiovascular disease. The second is the cancer. This is the result from the observational study. The data from China, we can find the rural area. The CVD mortality rate is about 46% people died from CVD. In rural area is this show the rural area. This is the upper area. Upper area. This is upper area. This is rural area, countryside. This is city people. We can find the CVD mortality rate is about 13.55%, and that means about 14 people died from CVD in upper area in China. There are about 46% people died from CVD in rural area. There is short slightly different CVD mobility rate from the countryside to city people. The second is the cancer. In rural area, in upper area, is 20% people died from the 26% people died from cancer, nearly 2 times the world average. 33 people died from cancer in rural area. This also shows slightly different between China countryside and the city area. This data also from the observational study I just showed you. This show the numbers of cardiovascular number of cardiovascular disease patient in China. The red one means the city upper area. The blue, the below one show the rural area, the countryside people, patient. The number of CVD in China is 313 million people have a CVD cardiovascular disease in China. 13 million the patient has stroke. 11 million coronary heart disease. 5 million pulmonary heart disease. 8.9 million heart failure, 4.87 million atrial fibrillation, 2.5 million rheumatic heart disease, 2 million congenital heart disease. There are other about the 14.5 million other artery disease. And in China, there are about 2,245 people. They are hypertension. This shows the numbers of the CVD patient in China. There's in China, the area also not is not balanced. For example, some people in the Heilongjiang province, they have a higher ischemic heart disease than Shanghai. For example, the death rate from the ischemic heart disease in Heilongjiang province was 4.2 times higher than that in Shanghai city. So the difference provides they have a different CVD death rate in China. This is I think it is easy to understand because Shanghai is a developed country, developed city. Heilongjiang is developing area, so the economic and the medical condition different. So mortality rate is also different. This is the data also from the observational study, the CVD increase and decrease. And 2013, China's ASCVD means atherosclerotic cardiovascular disease. Relative mortality rate is like to skyrocket by 17%. This means the ASCVD patient in China is a dramatic increasing. So the mortality rate in the field in China, the ASCVD patient will increasing dramatically. So in developed country, for example, in United States, the mortality decreased by 31% between 2000 and 2010 in United States, compared with the 2008 ASCVD induced mortality decreased by 0.8% in 2010. So in developed country, the CVD mortality rate is decreased. But in developing country, for example, in China, the ASCVD patient is increasing dramatically. So this is shows some different. This slide shows some of the features of the cardiovascular disease in China. The data also from the observational study. For example, the CVD mortality in China is 1.5 times that in the world average. I just show you the average mortality rate is 13%, but in China is about the 44%. This is 1 time higher than the average of the world. The rural area mortality is higher than urban area. I just show you the data from the observational study of China. The CVD mortality is increasing, but developed country are declining. So this shows some different. I also repeated some of the data show you. There are about 219 million CVD patients in China. So this is show the same in China. The web power 3.7 the CVD patient, CVD, the cardiovascular disease is 3.97 million people in China. The tumor died every year. Died from CVD is nearly about 4 million. Died from tumor is about 2 million. So CVD plus the tumor died people is about 70% of China, all people died. So this is the data, observational data from China. I just to show you cardiovascular disease. What is a cardiovascular disease? The WHO suggests the cardiovascular disease a group of disorder, the heart and the blood vessel, and they include the first one is the coronary heart disease, the second cerebral vascular disease, the third the peripheral artery disease, the fourth one the rheumatic heart disease, the fifth one the congenital heart disease. The sixth one is the deep vein thrombosis and pulmonary embolism. This is a cardiovascular disease. There is something there is something not I don't understand. From WHO, the hypertension is not a CVD. Some people think I think hypertension may be a cardiovascular disease. In China, the data from China think the CVD is the hypertension. Hypertension is CVD, cardiovascular disease. But in WHO, the CVD is the CVD do not include hypertension. There is some difference. This slide shows what happened to CVD. CVD deaths, 85% are due to the heart attack and stroke. A stroke, there are two different strokes. There are different strokes. You know, the first one is the first one we know the ischemic. The second thrombosis. So these are the different stroke. The heart attack and the stroke are usually acute event, mainly caused by the blockage and the private blood from the following the heart or brain. If the vessel block, there not enough blood to supply heart abroad, so the heart attack and the stroke appear. The most common reason of this built up the fat deposit on the inner wall of the blood vessel and supply the blood to the heart and the brain. So the atherosclerosis, the basic passage basis of the cardiovascular disease. Atherosclerosis gives the rise to the heart attack and the stroke through slowly progressing lesions formation at the luminal narrow arteries. The artery, for example, coronary artery and the brain arteries. So the heart and the brain not enough the blood to supply. So the heart attack and the stroke happen. See, this is the basic mechanism of the CVD. This slide shows the progression of atherosclerosis. The light vessel is a normal vessel. There's pain of layer. The first we know the interma, medial, and the vertical. This is 3 layers of the vessel, the normal vessel, and then there are some the fat lipid deposit in below of the interma. There is a fat streak. The fat streak. If we found the fat streak on the artery, we mean the atherosclerosis appear. Then the fibro, there is a fibro block, and the first and appear the complicated lesions. hemorrhage. For example, hemorrhage. For calcification happen. Calcification can be found in the arteries. So there is two cells in atherosclerosis. The first is the smooth muscle cell. The second is the macrophage. Macrophage become foam cell. The foam cell died. It become lipid core. This is the progress of this is show the progress of atherosclerosis. This is shows some pathology of atherosclerosis. The first, this is ApoE knockout mouse, give a high fat and a high cholesterol diet induced atherosclerosis. We can find this. The red one is atherosclerosis because the atherosclerosis lesions contain lipid. So the atherosclerosis lesions can be stained with red oil red wine or Sudan 4. So after stain, we can easily find the lesion. We can easily find the lesions. Just to show this. This is the normal arteries. This is the rabbit give a high fat, high cholesterol induced. 16 weeks we can find the appear. We can find the atherosclerotic lesions in aorta. This is some people human autopsy. We can find the aorta lesions. This is the people. This male people 17 years old. After the death, we can find there's complicated lesions in the aorta. So this shows some pathology of atherosclerotic lesions. We can find from the mouse, rabbit, and human beings. This shows also shows the histologic lesions of the atherosclerosis in cholesterol-fed rabbits. Rabbit is the most used to study atherosclerosis in human beings. This shows some advanced lesions. If this is HE stain, we can find this is the lesions of atherosclerosis. This is we can stain the macrophage. We can find the macrophage. Most cells in atherosclerosis in rabbit is the macrophage. This is shows smooth muscle cell. Smooth muscle cell we can find also from the lesions of the atherosclerosis in cholesterol-fed diet induced. This is show the early. This is show the early lesions. This is the above it shows the early. This below shows the advanced lesions. Atherosclerotic lesions in rabbit. In advanced lesions, we found the macrophage. The number of macrophage decreased. Macrophage decreased. Only we can find a few in the macrophage. In early lesions, we can find popular macrophage, but in advanced lesions, we can find only a few macrophage. This shows the early and we see the lesions of atherosclerosis in rabbit. In Japan, some disease was called model lifestyle disease. And here I want to discuss with you. The CVD is a model lifestyle disease. Is a model disease, not an ancient disease. I found some data. For example, from this is the below of the slide. This is shows the people is Iceman. Iceman was found from Italy. From Italy. Some from Italy. The people was the man was buried after avalanche. After avalanche, the 1 meter avalanche was buried under the ice. because climate is warming, so the man was found. So the man lived 5,000 years ago. 5,000 years ago. After CT scale, we can find that there is classification of atherosclerosis. This is we can find that in the ancient people there were atherosclerotic lesions. We can find. We know in Egypt there are many mummies. There are many mummies. Some mummies were scaled, use CT technique. We can find, for example, 3,006 years ago, a mummy. We can find there are lesions, there are severe, there are advanced lesions of atherosclerosis. For example, coronary artery, right coronary artery, left coronary artery. We can also find atherosclerosis. We can find atherosclerosis from aorta. We can also find atherosclerosis from iliac arteries. So from these two data, we can see that the CVD is not a model lifestyle disease. The CVD is an ancient problem. Because the ancient, we can also find the CVD. The second question is about the CVD is aging disease. If the people become old, they have the CVD disease. If the people young, there is not the CVD disease. So we also found the data from the JAMA. JAMA is very informed, famous journal in the world. In 1953, the JAMA publication a paper. The paper showed that 300 autopsies, the autopsies were performed in United States, but consolidated in Korean, the Korean War. You all know the Korean War. The Korean War. 80 years ago, China involved the Korean War. The Korean War is the Chinese war, is the China war with United States. So some Chinese soldier died, and also some American soldier died. So some American soldier were autopsy and found atherosclerosis. For example, the age from 18 to 48 9 years old soldiers. 17% soldiers were found as atherosclerotic lesions. So this slide shows me that the young man, they also have atherosclerosis. So this is I think this is the first time shows in people they have the young man have atherosclerosis. The paper is very important. The first publication in 1986, 1903, the first publication. The second, because this paper is a landmark papers, so the JAMA journal, the second publication, the paper, second publication. So this is a very short. The paper is very important. So the paper shows young people have atherosclerosis the first time. This slide shows the data from Japan. Japan scientists found the atherosclerosis can be found in fetus, children, and young adults in Japan. For example, the baby maybe has atherosclerosis early lesions. For example, fat streak can be found in baby. So from the above data, we can find that atherosclerosis can be found in fetus, children, and young men. So atherosclerosis, CVD, cardiovascular disease, is not aging disease. It can be also found in young men, in fetus and children. So I'll just show you some data from the observational study. Observational study have some usefulness and some reliability. So this slide shows some usefulness and reliability. The first one, for example, observational study provide information on real-world use and practice. For example, atherosclerosis is not model lifestyle disease, so it can be found in ancient patient. So the second usefulness of the observational study shows detecting about the benefit and the risk of the in general population. For example, we know that the hypertension, smoking, and others, the Western diet are risk factor for CVD in China. The third of the usefulness by reliability of the observational study can help formulate a hypothesis to be tested in subsequent experimenting. So observational study can give some information. The information can help us to perform next experimentation. For example, the blood pressure is a risk of the cardiovascular disease. If we lowering the blood pressure, that can be used for private cardiovascular disease. So the observationals give us some information, is important information. The first, the observational study provide part of a community type level data need to be designed more informative, pragmatic clinical trial. So give some information. The information can be used in clinical trial, translational study, for example. Smoking cessation treatment can be used, for example, can be used for treatment CVD. There are also some limitations of observational study. For example, observational study, I just show you, just only found what happened. You do anything for this study. So observational study results relationship rather constellate. So constellate relationship is different, well, very, very different. So constellate means cause and effect. For example, smoking and lung cancer have a greater correlations, but we can find the philosophy from the observational study. We can find the smoking and the lung cancer have a relationship, but we cannot confirm smoking must cause lung cancer. So if we confirm this the relationship, we must do the experimental study. So correlation is necessary condition. This is different. Correlation is different from concision. So this is some limitation of the observational study. The second biomedical study is the experimental study. So experimental study is easy to understand. We perform a study to perform. We perform a study to confirm a hypothesis. This study we call the experimental study. So experimental study is a procedure carried out where you find, refute, and validate a hypothesis. Experimental study provide insight to cause and effect. Cause and effect is very important for disease treatment. By demonstration, what outcome occurs when the particular factor is manipulated. So this is study we call the experimental study. There are three kinds of experimental study. First and most popular in Experimental study is a control experiments. Control experiments means compare results obtained from the experimental sample against the control sample. RCT means random control trial, pilot study. This is a control study. The second, the natural experiment, really solely on observation of the viable the system on the study. The last one is the field experimenters. Field experiment applying social science. We do some study in the natural science. This is about sometimes use the social science. So we do not discuss in our course. Very important is a controlled experimental study. Controlled experimental study in biomedical medicine can be classified basic study and applied study. The basic study is conducted to increase fundamental of scientific knowledge. This means basic study. Applied study is directed towards specific goals and discoveries, such as develop new medicine, medical device, and surgical procedure. We found new drugs. We found new procedures, for example, surgical procedures, medical device. This is applied study. Control study can also be classified to in vivo study, in vitro study. In vitro study, the in vitro from Latin means in the glass. If we do some study in bacterial cell, tissue, or organ cultures in laboratory, this kind of study we call the in vitro study. In vivo study means living. From Latin means living. They take place inside the organism. Experimentation done on in living tissue of the whole bodies. There are two types of the in vivo study. The first one, the pre-clinical trial and clinical trial. Pre-clinical trial means animal studies. Animal study assist research in test more effective method and diagnosis treating curing disease that affect both human and animals. Clinical trials means in human to study take place in hospital or clinical setting, involve the informed human volunteer and the patient to detect the drug, the procedure of the surgery, safety and the effectiveness of the drug procedures and medical device. So medical animal study is here. Animal study we also call the pre-clinical trial. This shows some different control study in biomedicine. In vitro study use material, use the tissue, use the cell tissue come from human being, come from animal, and come from plants. Application the in vitro study is the early and the intermediate research stage to study a single effect of substance in isolation. There is some limitations of the in vitro study. Culture cannot tell us how a substance affect complex animal system. For example, we cannot measure lipid levels, total cholesterol, triglyceride levels, blood levels. We cannot measure in vitro study. So this is a limitation. So I just show you cannot measure blood level, lipid levels. We cannot measure test the hypertension, the blood tensions. We cannot measure. We cannot test in vitro study. So in vitro studies are critical study of a virus that they can only grow in liver cells. So this is some limitations. In vivo study, the first pre-clinical study we call the non-human animal studies. Animal study provide the most reliable and complete data on the function of the liver system, They often offer the best indicator of the how humans will react to a new drugs or medical procedures. This is the animal studies. Show some information, very information for human being. So animal provide the best surrogate of the human in the laboratory. The animal also shows the same structure. For example, the cells, tissues, organisms, physiologies, pathology, the animal is same as human beings. The second involved study is human study. Human studies involved taking laboratory data on the safety and the effectiveness of new medicine, evaluating them carefully staged clinical trial using inform the human volunteer. And the animal study will be taken if we find a new medicine, new drugs for human beings. It nearly takes about 12 years from the initiation of the animal and other laboratory studies through the all phase of the human clinical trial, phase 1, phase 2, phase 3, and the submission to data to the governor of the administration, for example, FDA, for provider. It takes many monies and it takes long years, about 12 years, average about 12 years. It takes about the cost $1 billion. It takes. So for each new medicine provided, the cost I just showed maybe $1 billion of dollars. So this slide shows three phases of the human clinic. The phase 1 clinical trial determine the drugs of interaction with the human system, including how to the absorbed, how to the distributed, metabolized, and excreted, and like during its therapeutic effect. This is phase 1. It takes use small numbers of the health volunteer. It takes about 1 year. Phase 2, it takes about 2 years. It involved 100 to 300 volunteers. It was used to determine the drug's effectiveness. The phase 3 were conducted to confirm the result of the early efficacy test and further indicate of advanced reaction. It involved about 1,000 to 3,000 volunteers. It takes 3 years. This shows some data of the. This shows some data. This shows of some study about a clinical study, and a preclinical study. We call the animal study. Okay, have a break. 3 minutes. Okay. Okay, let's continue. Sure, we give you a sample about we use animal to study experimental study. For example, I just show you the CVD mortality rate is the first killer in the world. So we should do some medication for the CVD, cardiovascular disease. I know the first one of the most important risk factor of the CVD is high cholesterol diet levels in human beings. So the first important drugs is statin. Statin is the main drugs for the CVD because statin can decrease blood cholesterol levels. So it's very important drugs for CVD. However, certain percent of CVD patient cannot properly treated by statin alone. And this is because this patient take the statin cannot decrease the blood cholesterol levels. So there is no reaction for these people, 0% patient. The second, for some people, the blood cholesterol level is very, very high. If they take more and more statins, there is a ruler of the 5 and the ruler of the 7. We average is 6 rulers of lipid lowering by statins. It means if the dose increase two times, for example, the milligram, we take the statin milligram one day, and we increase the 2 times the dose, the 40 gram one day. But the 40 gram result to increase blood cholesterol level lowering result is 6%. It is compared to 20 milligram treatment. So because there are 2 limitations of the study, new therapeutics are needed. We collaborated with a Japanese pharmaceutical company. We wanted to provoke cholesterol and study cholesterol and study compound to treat some people. Propofol is a powerful
Meanwhile, teacher,
antioxidant.
would you please explain the last slide?
Last slide. Can you find my slide?
Just last slide.
Last slide. We show the number the 40 slide. Last slide is the 115 slide. Can you find my slide? Just slide the medication of
Yes,
CVD?
yes, lovely. Just this slide. Please again explain, please.
Explain. You don't understand this study meaning.
That's it, lovely. I just skip this slide.
You skip this slide. You don't find this
Yes,
slide.
yes.
You can. This slide
Thanks,
shows
lovely.
the medication for CVD. The very important medication is treatment of statin. Do you know statin? Statin is the main drug for CVD. But some percent CVD patient cannot treatment by statin alone. If the statin dose increases 2 times, but then lowering lipid is increased only 6%. So this is 2 limitation of the studying for treatment of CVD. So new treatment are needed. This is we do some studies to some animal studies about the we wanted to studying plus propofol plus cilostazol for treatment the human beings. We cannot treatment with statin alone. So probucol is a powerful antioxidant which inhibits oxidation of the cholesterol in LDL cholesterol. Cholesterol is inhibited platelet aggregation and is direct artery vasodilate. So probucol plus cilostazol combined maybe become potassium candidate. So we do some research. For example, we give the rabbit cholesterol diet induced atherosclerosis. This is a control. This is we give the cilostazol. This is a rabbit we give probucol. This rabbit we give cilostazol plus probucol. We can find atherosclerosis area decreased. This is the last. This is another experimental rabbit. This is starting alone. This is probucol plus cilostazol. This is a probucol. This is a probucol plus cilostazol plus study. 3 drugs combined treatment. We can find three drugs combined treatment is better than probucol plus cilostazol than starting alone treatment. This shows me combination may be better than starting treatment alone for atherosclerosis in rabbit. This is a study, experimental study. So this study shows some observation, compare observational study and experimental study. The key difference, these two studies is a relationship. Result from the observational study is a relationship, but from the experimental study, the concision. This is key difference. For example, people who smoking are more likely to have liver cancer. This is statement of the correlation. The relationship indicate one thing causes another. For example, smoking causes liver cancer. This is a statement of causation. So this is a key different. Relationship, correlation, or concision. This is different from the observational study and experimental study. Of course, there is some limitations of the biomedical research of the observational study and the experimental study. There is some limitation. For example, many experimental studies they would be able to prove a relationship would also be unique to perform. For example, research may not to perform experiment to confirm whether smoking gives human cancer by taking a group of people and force them to study smoking. This study cannot become unique for human beings. This is some limitations of the experimental study. For most medical research is a observational study and experiment combined. Observational study combined experimental study. This is a general speaking. A full biomedical research. It should be done. Observational study combined with experimental study. For example, when we confirm of the passage of infected disease, there is a cohort postulator. There is a 4 criteria were established by robot cohort to identify the causative agent of the particular disease. This include the pathogen, the microorganism or other pathogen must be present in all cases of disease. The disease comes from human beings, the disease from animal, and from the plants is also okay. the passage can be isolated from disease host and grown in pure cultures, the second criteria. The third criterion is the passage from pure culture must be caused disease when inoculated in health suspectable laboratory animal. The fourth criteria, the passage must be isolated from new host. New host means the laboratory animal and sure to be same the original inoculated passage. This is a cohort postulate. This is a very, very famous postulate. This is we found some microorganisms present in all cases of disease. This shows. Sorry. The first Korean is the observational study. The second and the first one is experimental study. The last one, the passage must be re-isolated, also is observational study. So cohort postulate is also the observational study combined with experimental study. This is a sample show for you. We know that we confirm the SARS-CoV-2 is a passenger of the COVID-19. We also use some scientist, Dr. Atiq in Beijing, do some study. He give the transgenic ACE2 mouse. Transgenic, the ACE2 mouse, the transgenic mouse expression human ACE2 genes. So the SARS-CoV-2 can infect this mouse. This shows the animal study, shows and confirm the first, and confirm the first, the SARS-CoV-2 is the passenger on the COVID-19. So the data publication in Nature. This sample is, the study is not so difficult, it's not so complicated, but it shows, it shows the cohort postulate. This is very, very important. For biomedical research, the clinical discovery relationship, this is the observational study. For example, we making you test, you measure the mRNA levels from cancer tissues and peri-cancer tissues. This is shows some observational study. So you do some molecular the function genes. You introduce a gene to the cell line and find the gene function. This is experimental study. Validate the animal models. For example, you transfer the tumor cell lines to a mouse. The cell lines grows in the mouse body. This is experimental study. You study back to the clinical validation. You found some data from the human being, for example. This is the observational study. So for biomedical research, biomedical study should be combined observational study with experimental study. This is show you some method how to perform animal study, how to perform biomedical study. The second, today I will introduce you some why are animal need in biomedical research. So we do some animal studies. When do some experimental studies, sometimes we use experimental materials for biomedical study. The material include five different types. The first human being, human volunteer. Back use is lacking controversial. So most study cannot be studied in human being because it euthanasia. So the second laboratory Of course, we can use animal embryos, organs, tissue, and cells of plant, animal, human beings. But this is in vitro study. There are some limitations. I just show you. We cannot measure, for example, lipid levels. We cannot measure blood pressures. We cannot measure blood sugars. We can also use bacterial, fungi, and non-organisms, but the function of the physiology and the pathology is different from human being. The last time we can use computer models, physical and chemical products, and another uneven body alternative models. Sometimes this model is useful, but most the models result cannot be transferred translation to human clinic. So laboratory animal study is very important. This slide shows some history animal experimentation on the progress of the biomedical. For Aristotle, for example, Aristotle developing medical treatment based on anatomic finding of animal and observational surgical cases. For example, Vesalius found the anatomy father, we call anatomy father, anatomy father. He compared the anatomy findings of the human with other animals. Harvey will not discover the circulation of the blood. So there are many progress in biomedicine history. This slide shows the contributions of animal experimentation to the progress of biomedicine after 19th. For example, infections, cardiovascular disease, diabetes, organ transplantation, and others. There are many progress in biomedicine, renal animal studies. For example, the U.S. Congress Office of Technology Assessment and the National Association for Biomedical Research from USA, they found approximately 17% American public sports necessary use animal study, use animal in biomedical in biomedical research. That means 17% project involved in animal studies. This shows the Nobel laureate from this year. There is about 112 Nobel Prize award on the physical on medicine. 99 were directly depend on the animal research. This means nearly % animal study involved in Nobel Prize in the field of physiology and medicine. This is all new data about the Nobel laureate from this year to 2022 this year. In fact, there is 225 award recipient. There is 225 Nobel laureate in the field of the physiology and medicine. 188 use the animal models in research. This means 48% Nobel laureate in the physical on medicine area. Their result come from the animal study. Most of our discovery required 2 on 3 species of animal used. So this shows some data show the animal study very important in biomedicine. For example, 2013 discovered the mechanism regulating vesicle traffic. They use mouse knockout mouse model and a rat. 2014, they found inner GPS of the brain use the rat. 2015, novel therapies for treating parasitic infection. The Chinese scientist Tu Youyou become a Nobel laureate in the natural science. This is the first Chinese person. They use chicken, cow, dog, horse, mouse, pig, rabbit, rat, and sheep to use this animal help them find the treatment for parasitic infection. For example, 2016, Japanese scientists become Nobel laureate because they found the autophagy. They use mouse. The 2014, they found circadian rhythm. They use fructiferin. 2018, for discover cancer therapy, we know that PD-1, they found use mouse. The 2019, because they found the cell and the cell sense and adapter exchange of availability, so they use mouse. Sorry, this is a 2020. They found the HCV and found the treatment for HCV. They use a human being prombate. Last year, they found Nobel Prize. They found discovered the receptor of temperature and touch. They use a mouse. This year, Nobel Prize in medical, in physiology or medical, because they found ancient was performed the ancient DNA detecting. They do not use animal studies. They use new techniques. He don't not use animal study. This shows some data for them Nobel laureate. So animal study, for example, basic biomedical, sometimes for basic biomedical research, also used in cardiovascular research. This shows the Nature Medicine. We know the very important Nature Medicine, very important journal in the field of the biomedical research. We can find that total people in 2012 publications. Total is publication is 128. 108 the publication involved in animal. I just show you, we do some study in atherosclerosis in our laboratory. We do some study in atherosclerosis in our laboratory. So we found some 5 top journals in atherosclerosis. The first one circulation, the second circulation research, the third one the atherosclerosis, thrombosis, vascular biology, we call ATVB. The third famous journal from AHA, American, very famous. The cardiovascular research, atherosclerosis from Europe, very famous journal. We check all the paper publications from this paper, from those 5 journals. We found the total papers is in 1912. Atherosclerosis related article is 423. 184 involved animal study. 188 used human beings. 15 performed study in vitro study. This shows that some animal study also important in atherosclerosis. So from the above discussion, we can find most biomedical research use animal studies. So animal study is very important in the field of the biomedical research. And then you may ask why animal need in biomedical research, biomedicine. So there are two reasons. The first, animals are necessary to medical research because it is impractical, illegal, and useless to use a human being in the early phase of the research. We can use animal study. We can use the human being study. So use animal is okay. Animals make good research subjects for variety of reasons. First one, animals are biologically similar to human beings. The second, they are susceptible to medicine health problems. Some species, for example, mouse, generally have a short life cycle, so they can easily to be studied throughout their whole lifespan. Crosses are easy to cross several generations. One generation it takes about 10 weeks. 10 weeks, one generation in mouse. So it's easy to study several generations in mouse. The third reason is scientists are easy to control environment, too easy to control the genetic, too easy to control microorganisms around the animals. For example, diet, temperature, lighting, genetics, SPF, which could be difficult to do in human being. So we can, this is the short reason why we use animals. This slide also shows the animal models for human atherosclerosis. We use animal to improve understanding the molecular mechanism behind the atherosclerosis plaque, atherosclerotic neurons form and progress to access new pharmacological treatment that can prevent and slow the onset of atherosclerosis. This sample shows why we use animal models to study human atherosclerosis. And the third one, I will introduce and just discuss with you. Animal study is very important in human beings. Animal study also very important in animals, because we found some new medicine is also used in animal disease. So we can see that animal study is beneficial for human beings. Is also beneficial for animal himself. And then next we will discuss with you what kind of animal used in biomedical research. At first, I will discuss with you what is laboratory animals. Any lives vertebrated animal used intended for the use of biomedical research, testing, teacher, or biological products. This kind of animal we called laboratory animal. So a laboratory animal often defined as an animal special breeding for biomedical research to meet the requirement biomedical research, teaching, medical treatment, assessment, diagnosis, and manufacture of the biological products. For example, to generation vaccine, we sometimes use animal. So laboratory animal are artificially breeding and reproduction to the standardization species or strain. This kind of animal we called laboratory animal. Laboratory animal differ from economic animal, differ from pet, differ from animal in zoo. So this is a special animal type. So used for biomedical research, teaching, biological production, and so on. So this is a definition of laboratory animals. Where scientists get the animal? For example, we wanted to some study. We wanted to use animal. Well, we can get the animal, laboratory animals. Animals we can buy from species animal breedings, laboratory animal factory, and laboratory animal company. For example, very famous in the world is the Charles Rivers Jackson numbers. Jackson number can provide the mouse string. Nearly all mouse string can be kept in the laboratory, kept in the Jackson number. So the animals most commonly used in research are mouse, rat, and other rodents. These animals are breeding for research. Scientists purchase them from the animal breedings. For example, Charles Rivers Jackson in China. Our laboratory animal center, 西安交通 University. We also we also breeding some animals for mouse and rat for some scientists, for students to use. Every year, we generation about 0.1 million, nearly 0.1 million mouse and rat for scientists to use. So we also sell the laboratory animal. In China, for example, 脊椎药康 also sell. Also, you can if you do some studies, you can buy the laboratory animal from, for example, from our laboratory animal center, from some special companion. You can buy from Charles Rivers Jackson laboratory. So other animals are sometimes used in research, including pigs, sheep, dogs, cats, and other farm animals. And the non-human primates you can also get from the species companion. So if you want to do biomedical study, you can buy you wanted animal string from a species companion. And now you may ask how many animals are used in biomedical research in the world. Example, from the idea, I don't know. I think there is no exact number how many number of animals used in biomedical research. Nearly all data is estimated. All data is estimated. So this slide shows some data. Use some animal numbers use different Europe and other countries. For example, in European Union, about 11 million people died. Meaning animal used in biomedical research. This data showed some data. This short data is more, I think, maybe exactly. This data shows some of the animal number used in different countries. In China, I'm sorry, it's Chinese. I don't change it in English. The first one, this is China. There are about 20 million. There are about 20 million animal used in biomedical research. In Europe, I just show you. In Europe Union, it's about 12 million laboratory animal used in biomedical research. In America, there is no exact number of how many animal used in biomedical research. So animal numbers in United States is estimated number. This also shows some data, some available numbers of the animal used in biomedical research, include the dogs, cats, guinea pigs, rabbit, hamster, and other, but exclude rats, mouse, and bird. This shows some number of species in United States in 2014. This slide shows the tendon of the animal numbers used in different countries. The first one is Union. This Europe Union. This is the Europe Union. The number of the animal used in Europe Union is decreased. This is England. This is American. This shows China. China, the animal labs in China is decrease is increased rapidly. The animal numbers every year increasing. This is same as China economic also increased. So the animal numbers used in biomedical research is also increasing. This shows the numbers in German animal numbers animal research procedure in German. This slide very exact number used in the UK. Very exact numbers used in UK. We can find the percent procedure used in the mouse. So we show the most popular in biomedical research. The species is mouse. This shows the mouse. This shows the mouse and the rat. The percent in China is about 76%. Animal is a mouse and a rat. And now in China is the most popular used animal is the mouse, the rat. It is about the 87% laboratory animal used in China is mouse and rat. This slide shows the third animal used in England from the 1914 to 2014. This slide shows different species used in different countries. This shows Europe Union, the first population animals is the mouse. Second is the fish. Third is the rat. This England, the first is the mouse. Second is the fish. The third is the rat. This shows in China, the first is the mouse. Second is the rat. The third one is the rabbit. So this is different because Europe Union and England is the ocean country. So the fish popular used that in China. China second species the mouse, rat. The Europe Union and England the second species the fish. This slide shows the arrow basic research. This is the basic research. This is the applied research. This also shows the different basic. This slide shows numbers, animal numbers used in basic research. This is the show animal numbers used in applied study. This data from the Union, European. This data from the Europe Union. These publications numbers, we check the data from the Web of Science. The publication mouse increased from year to year, but the publication use the rat, the decrease the publication. Rabbit also decrease. Rabbit also decreasing. Dog, the public dog related publication increasing. This is the guinea pig, hamster pig, and the human primate. Those show some trading of the publications use different animal species. And the last, we also summary why animals are used in biomedical research. The majority of animals in biomedical research is the mouse and the rat and the fish I just showed you. It is estimated that is estimated that 18% animal used in biomedical research is mouse and rat. So mouse and rat are used to screen promising drug treatment for disease and host surveillance and to test products of toxic species inbreeding mouse. Now are breeding used to determine how species gene function. Dog, cat, and non-human beings occurred numbers for biomedical research is below 1% of animal used in biomedical research. The second features of the trait of laboratory animal is in biomedical research is a genetically modified animal. We call GM animal become the king models for carried biomedical research. For example, this is the data shows the genetic GM animal used in England. We can find from 2012 from this year, the numbers of the GM animal is greater than the normal animals. So GM animal become #1 animals used in biomedical research. So I just show you the data. The publications from the Nature Medicine in 2012. In 2012, 10 years ago, we can find animal studies publication 107 publications use animal study. In this publication, 100 is genetic modified animal. So this slide shows that genetically modified animal is very important in carried biomedicine. We just also show you the animal study publications 184. In this over publications, 162 is use genetic modified animal. Also shows in atherosclerosis study also shows this GM animal is the king animal model in biomedical research. What is GM animals? Animals. I think there are 4 types GM animals. One is a transgenic animal. Second is low count animal. The third is lock-in animal. The fourth is low count animal. What is genetic animal? Genetic animal means a new gene from same or different species is introduced in a genome of the animal. So the animal carry the new gene can generation can genetic from one generation to generation. This is not transgenic animal. The second is low count animal. Low count animal means target remove a gene or portion of the gene from the genome of animals. So the animal strain that has no special gene function. The special gene were removed from genome. This means the low count animal. Lock-in animal means targeted addition of gene. Addition of gene were introduced to the genome of the animal strain. This is the lock-in. The last one is a lockdown. Lockdown means silence endogenous of genes. The gene's function is decreasing. This means lockdown. The most used GM element is transgenic and lockout animals. So this is transgenic and lockout animals. This slide shows how to creation the transgenic animals. For example, how to creating transgenic rabbits. This slide scheme of the creating a transgenic rabbit. So the male and the female rabbit meeting, we can collect some of the embryo, the new gene or injection, nuclear. After introduce nuclear, new DNA of to embryo, and embryo will transform. The new baby, new offspring may be carrying the new genes. So this is we can find the transgenic rabbit Korean new genes. This is transgenic rabbits. So transgenic animal models the first created by Random in Yale University. The first in 1980s. In 1980, the first publication published in PNAS, PNAS USA. So in 1988, see, this is shown. This slide shows the traditional method to generate lockout for locking mouse. This slide. So this technique is complicated. So Dr. Bell will introduce the technique for your detail. So this only the slide only shows the scheme of the how to creation lockout mouse. So because the scientists, the three scientists, they use a method to creation the lockout mouse. So they award the Nobel Prize. They become a Nobel laureate. This slide scientist, the three scientists. The new stage of creating lockout animals, for example, ZF talent. This is a new technicians for creation the lockout animals, but more very new technicians appears for we call the CRISPR-Cas9. Use this CRISPR-Cas9 is very simple. We can use this technique. We can easy to create a lockout mouse, lockout rabbit. Nearly animal models can be create lockout use the CRISPR-Cas9. So I don't know when you wanted to create a lockout mouse, nearly all people use the CRISPR-Cas9 techniques. So the two scientists discover the technique CRISPR-Cas9. They reward the Nobel Chemical Prize 2020. So the two scientists, the female scientists. Okay, we have a rest. Take a break. Okay, 10 minutes. Okay, 10 minutes. Okay, let's come back. 4 hours is a time of too long for us, but the course is set 4 hour one time, so I have to do. So the certain hour, the certain hours let's begin. I just to show you the GM element, genetic model found element is the key element models in biomedical research. The GM element, the first very important element model is transgenic element model. The second I just show you is lockout element models. This slide shows how to creation the element transgenic element models use macro injection. The first we can prepare the external genes, transform genes. The first we can prepare. The second we have to connection fertilized angles. We have to connect many and many angles. Then we perform macro injection, DNA injection. The first one we perform the improved transfer. The last one we identified new Berbers. New Berbers was born. We have to identify of transgenic animals. So this is short 5 steps how to creation the transgenic animal model using macro injection. The first, when we do macro injection, we have use machine. This is show machine macro injector. Macro injector. This is show the machine. This is show the machine how to prepare needles for macro injection. This is the machine. Shuttle instrument. This is the machine. This is show the Dr. Zhou, Professor Zhou prepare needles for macro injection in our laboratory. This is show the prepare the transgene, how to prepare the transgene. For example, when I study in Japan, I prepare a transgene of VEGF expression constructor. We use VEGF cDNA, use a promoter, use a promoter antityping promoter. We contract the exon genes. We clone the genes in vitro, so we get the transgene. The second, we collect the fertilized eggs in pro. This slide shows how to collection the rabbit in pro from female rabbit. This shows how to collection, how to create connection in pro. This shows the macro injection, DNA macro injection. There are 2 needles. One is holding, one is the injection. The DNA in the injection needles. So this is show the improved rabbit. This is male nuclear. It's female nuclear. We can inject the transgene in the male nuclear. After injection, we can find the nuclear of the male nuclear is become large. So this shows the successful macro injection. Then perform the embryo transfer. This after new puppies were born, we can use PCR. We can use other method to detect whether there is a transgene in the animal. So this shows the method. For example, we can check the MR expression in transgenic rabbit, in the control rabbit. This is method. So this shows how to creation lockout transgenic animal models. This slide shows the common species, animal species in the biomedical research. The most popular used is the mouse. The second is the rat in China. In Europe, in Europe Union, maybe the fish. Guinea pigs, Syria hamster, Mongolia German, rabbit, dog, and cat are most popular animal species used in biomedical study. This slide shows the animal domestication time. For example, the dog has domesticated nearly about 15 15,000 years ago. The other animals, for example, sheep, goat, pig, cat, about 10,000 years ago. Others, for example, dolphin, yak, and water buffalo, domesticated about 5,000 years ago. Rabbit domestication history is very short. It's about 1,008 6 years ago. So this shows some animal used in biomedical research, domestication time. Common laboratory animal used in biomedical research. The first common used animal strain is mouse. Mouse, the species name is a mouse class. The very famous mouse is C57BL6. This is very, very famous. This is inbred strain. The genome species have finished 2002. So this is the most popular used mouse strain in biomedical research. We can also find some different animal strain, mouse strains in biomedical study. For example, bubble C mouse and envelope is white. The B6 C57BL6 is black. This is mating. B6 mouse with C3 mouse mating, the first one generation. This is this nude mouse. Nude mouse is T cell deficient, so can transfer human tissue to nude mouse. This show different mouse strains used in biomedical study. This is also mouse. Mouse in China is very famous outbred strain, Kunming strain. Kunming outbred strain, we can call the KM strain, most used in China. This study shows the original mouse or original mouse. For example, mouse class species become 4 subspecies. So they combined and become the laboratory mouse and are now used in biomedical research. For example, we want to study the manual way in atherosclerosis. We have to we create a knockout mouse, the middle one knockout in macrophage. So we use the ApoE knockout mouse and macrophage knockout mouse, double knockout mouse. We can find the ApoE middle one knockout mouse, the atherosclerosis measures increased. So we can see the middle one is proactive. Middle one is proactive for atherosclerosis by regulating macrophage polarization. This is a mechanism. So we can, for example, we can find this is a sample. There are species strains on the mouse strain also used in tumor study. For example, immunodeficient mouse strain is very, very famous, used in tumor studies. For example, nude mouse, NOD skid mouse, NOD skid mouse, NSG, NPG, NOG skid mouse, NOG mouse, the most severely immunodeficient mouse, was used in biomedical research. For example, this nude mouse has anemic T-cell immunofunction defect. This is shows the features of NSG mouse. NSG mouse is the most severe immunodeficient mouse. This is shows some features, some character the mouse NSG. So this slide shows the applications on NSG mouse. For example, primarily human external graphite that perceive the tumor environment during long time in graphite. Humanized model can be created by user NSG mouse. So this shows some features NSG. So this is a PDX model. So immune mouse model can be used create a PDX model. What is PDX model? PDX model means the patient derived tumor xenographic models. So means PDX models. Human tumor can be transferred to mouse, to immunodeficient mouse. The human tumor tissue can be grown underground. So we can study human tissue in the mouse model. This model we call the PDX model. PDX model can be used brain clinical study. This slide shows design, shows the scheme how to use PDX model to study human medicine. This shows how to show the PDX model. PDX tumor become large. So this shows how to measure tumor size in our laboratory. For example, this is a gastric cancer. In our laboratory, we use PDX model. PDX model, we can find the tumor size become large and large. This is number 4, number 4, 5, number 3, and number 1 different mouse. We can find there is a slightly different tumor size. The second species most used in biomedical research is the rat. Atiq, novigas. This is a species name. This is shows rat. Rat and the Fisher 344 is the inbred string. Brown novi, nude mouse, and SHR. SHR means spontaneously habitation rat. Is most used for human study human habitation. This shows different species used in biomedical research. Use a rat species. The third most used rodent animal is cereal hamster. This is short Sima harrister. This is a cereal hamster. The fourth is the guinea pigs. Guinea pigs originate from the South American. South American was used as a root animal, as a meat animal, and now it is very famous and most used the laboratory animal. Guinea pigs, different kind of the guinea pigs. Rabbits. This is shown the rabbits. This is Lagomorphia species in Lagomorphia. All the rabbits in biomedical research come from the Euro rabbits. This is Euro rabbits, originally from 160 years old. 600 years old. This is some original of the domestic rabbit. This is a rabbit used in biomedical research in our laboratory. Then this is show the variation of the rabbit string. But all the rabbit originate from the Europe rabbit, and I think order from several rabbits. So this after 1,600 years breeding, they show the different features of the phenotype. This is also show the medium size breeding, small size breeding of the animals. We also do some study. We also do some studies use animal rabbit model to study atherosclerosis in our laboratory. This is I visited the animal facility in Japan laboratories. So in our laboratory, we use a rabbit model to study atherosclerosis of human. For example, we recommended diet for the atherosclerosis for the cholesterol-fed diet. The cholesterol content should be 0.3 to 0.5%. Never use above the 22% cholesterol diet. So this is our suggestion. When we give the rabbit the cholesterol diet, the blood total cholesterol level is increased dramatically. This is showed. For example, we use 1% cholesterol diet. We use 0.3 cholesterol, 0.3% cholesterol diet. We can find the total cholesterol level in rabbit blood is increased dramatic. So the rabbit appear atherosclerotic neurons. So this is I just show you the advanced neurons, atherosclerosis in cholesterol-fed rabbits. So for example, we use a transgenic rabbit to study the rotation two the function in macrophage. So this is some study in our laboratory. For example, another species, common laboratory animal species is dog. There are many different strains, different line of dogs. But in biomedical research, the only one used is big dog. Big dog come from England and now become famous as a animal, laboratory animal. This is a picture of the big dog. Some are cat, mini pig. This is show mini pig in China. And monkeys, for example, this monkey we call the crab-eating macacos, because this monkey pick up the crab in the ocean side to eat. So we call this monkey crab-eating macaco. Because they have a long tail, so we call the long-tailed macaco. The scientific name is Cynomogas monkey. The second most used non-human primate is rhesus monkey, Macaca malata. This is also most used in biomedical research. Cat, goat, sheep, they also sometimes used in biomedical research. Fruitiferin is also used in biomedical research. This shows a small worms, elegans, C. elegans, because scientists use C. elegans to find apoptosis. So the C. elegans becomes the famous animal models. C. elegans. This shows C. elegans. Zebrafish also sometimes used by medical research for developing the biology. Sometimes people use zebrafish because fish has a zebra has a band of like a zebra, so the fish zebrafish. This Himalaya mammoth. In our laboratory, we do some research of mammoth. This slide shows the Himalaya mammoth. There are 14 species of mammoth in the world. The four species mammoth can be found in China. The other in the other world in the other country of the world. So very famous mammoth in China is Himalaya mammoth. Our laboratory do some research of Himalaya mammoth. We first time sequencing genome of the Himalaya mammoth. This shows some features of Himalaya mammoth. This is our result publication published in iScience, this journal. So this is this journal publication our Himalaya result mammoth. So this we can find and Himalaya mammoth picture from this journal, the picture from our laboratory. So this is some news from internet. We can find they introduce our laboratory, the works about Himalaya mammoth, genome sequencing. August Krov, the Nobel laureate. Because he found muscle circulation, macro circulation. He reward a Nobel Prize and become a Nobel laureate. Nobel laureate. So in 1929, he published a publication in AJP, American Journal of Physiology. In this journal, he said, for such a large of problems, there will be some element of choice on a few such elements on which it can be most conveniently studied. This is the view of the against become called principle against crop principle. In 1975, another Nobel laureate, Caribbean become find TCA. TCA means tricarboxylic acid cycle. TCA, because for TCA, he also became the Nobel laureate. He publication in the journal experiment of the zoology. In this journal, he summarized August Krov principle. He said, Krobitz said, for many problems, there is an element on which it can be most conveniently studied. That means August Krov means that when we do some biomedical study, we can find the animal models can be conveniently studied. We can find the animal study for biomedical study. For animal, we can find the animal models for our medical studies. This is a summary the August Krov principles. There are 5 teachers will introduce our cons to you. First, I will introduce the animal models and biomedical study today. Dr. Wang Rong graduated from the University Maryland, USA. He will introduce some course and he will follow you visiting our laboratory animal facility. Dr. Wang Weirong studied in University of Washington, Seattle University. He will instruct you to perform the basic experimental technique in mouse. Dr. Bai Liang graduated from Northwestern University, USA. He will instruct you perform basic experimentation in rat and rabbit. Dr. Zhou, he is also professor in our laboratory. He studied in Stanford University, USA. He will show you transgenic animal technicians. So this is for our laboratory, four professors in our laboratory, and we'll teach you the laboratory animal science at instruct the animal study. For example, you should learn how to holding and restraining the rabbit mouse, how to identify the sex. For example, this male mouse, this is the female mouse. We can find the distance. The distance is long in the mouse. As the female, the distance from the genital to anus, genital opening to genital, the distance is short. This female. This slide shows how to sex identification. This slide shows how to animal mark when you studies, how to marker inject, how to subcutaneously injection, how to treatment, how to give the animal drugs. This slide shows the oral administration by garbage for rat. The first one I will introduce you about standardization of laboratory animals. For this slide shows the responses of to treatment in animal studies. We can count the response to treatments. We can also we think it as a results. That means animal response to common animals. Being as animal, for example, use species. For example, use animal study, use mouse or use rat. For example, the being the gene manipulations. For example, use a transgenic or lockout mouse model. The C means genetic microbiology control or on response to species to individual. For example, you use male animal or female animals. D means in vitro environmental controls on effect of environment to animals. E means stress, control pain and stress. Stress and distress, pain and distress may be an factor of the animal result. F means experimental error. So standardization laboratory animal. So we should give the treatment control group animal and the treatment animal group the same conditions. This means standardization. So standardization can be divided to four standardization. The first one means genetic, the second microbiologic, the third one environmental, the fourth one is nutritional standardization. The first genetic standardization, all laboratory animal are genetic, all animal can be divided into classified three types. The first one inbred strain, the second outbred strain, the third F1 hybrid. The most important in mouse is the inbred strain. Inbred strain is the result 20 or more continual generations of a single pair. For example, brother and sister mating. Brother and sister mating, every generation, brother and sister mating continue and continue over 20 generations. We can create a new breed strain. This strain we call inbred strain. So this means inbred strain. There are many inbred strain mouse available. There are also inbred rat, inbred hamster, inbred rabbit, and inbred other animal species, also used in biomedical research. This shows some features, some characteristics of the inbred strain. For example, all inbred strain is homozygosity, isogenicity, uniformity, long-term genetic stability, identifiability, individuality, international distribution, bank grid data is clear. So this is showed 8 features of inbred string. This slide shows some inbred string used in biomedical research, bubble C, CB6BL, BL6. This mouse we also called B6. So this C3H mouse show different commonly used inbred string. The second is a F1 hybrid. F1 hybrid is the first generation cross between 2 inbred string. 2 inbred string, for example, inbred string A and the inbred string B mating, the first generation we called F1 hybrid. F1 hybrid has some inbred string, has some features of inbred string. This is F1 hybrid. This slide shows how to create F1 hybrid. This shows some features of inbred string. Shows some features F1 hybrid. For example, B6 mouse bank meeting with bubble C. The F1 is super mice. For example, this mouse F1 hypoxia exercise time is very, very long. Is long their father, their mother. So the mouse color is also different from their father, from their mother. This is the third one is the interbred string. The interbred string are generated from the two genetic dissimilar string of the same species. So very famous interbred string in mouse as the ACR created from Institute of Cancer Research of American. We call this mouse of ACR. In China, interbred mouse is KM, the common interbred string, the most used. In China, about 500 KM mouse used in biomedical research. This shows some interbred mouse string. This slide compared the inbred string, F1 hybrid, and interbred some characteristics. If you're interested, you can find some difference. You can some commonly from the three string mouse, inbred string, hybrid, F1 hybrid string, interbred string. There are different string mouse available. When you do some study, you should choose how to choose inbred string, interbred string, how to choose. When you do some study, you use mouse. Most people use inbred string. When you do some study in rat, most people use interbred. This is published data shows. Our laboratory also found the most used the most population used in mouse is inbred string. The most population used in rat is interbred string. The second standardization is macrobiological standardization. Laboratory can be classified according to numbers of different macrologic qualities can be classified 4 types. Conventional animals. Second is SPF animals. SPF animal means specific pathogen-free animals. Not biotic animals or germ-free animals. So this is a different quality, different macrobiological quality levels. Animal can be classified different levels. Conventional SPF, GN and GF animal models. What is SPF? SPF means animal that showed no evidence of a presence of a certain microorganism. such as absence of particular disease, cause of virus or other microorganism. All rodents used in biomedical research must be SPF sure. Facility. The third standardization is environmental standardization. So this is related to animal facility. Animal facility, there's 3 levels animal facility. The first is the conventional facility. The second is the burial facility. The last one is isolated. The conventional facility for conventional animal, burial system for the SP animal, isolated for the germ-free animal. So this is the different levels animal facility. This is also show different levels animal facility. This is the animal facility in Yenta campus, the Yenta campus of our university, animal center, animal facility, 西安交通 University in Yenta campus. This is the animal facility in Saga University. I studied here. I received a PhD in Saga University. So I stayed this animal facility over 4 years. This animal facility in Saga University. This animal facility, this animal room for breeding dogs, for breeding pigs, for breeding rabbit in our animal facility. This is also shows animal facility in American. We found in American. Animal facility in cage levels, individual ventilated cage, we call the AVC. The AVC is small facility, animal facility. So this is show the AVC. This is isolated. Isolated is for keeping germ-free animals. This is new campus in our university. We call the innovation harbor. Innovation. We call this innovation harbor. New campus of our university. This is our new animal facility. The new animal facility will be used at the end of this year. It is built very well. This shows some features of new facility, shows some teachers of new facility. So the last standardization, the nutritional standardization, show the animal diet, animal feed, and water should standardization. Animal diet, animal feed, and now you should buy from the species companion is a species factory, diet factory, diet companion is okay. The water is for animal drink is sterile water is okay. So there is some technician for water for making sterile water for animal drinking. Okay. Have a break. Okay, 10 minutes. Okay, let's begin. Next, we will discuss with you about the ethics in animal study, in animal experimentation. Because all elements in animal studies, all elements suffer from the distress, some suffer from the pain. This is in fact all elements, nearly all elements suffer from distress, some suffer from pain. So some people, they are against animal study in biomedical research. They oppose animal studies. So this shows some figures, demonstration. They show that the animal test animal study should be prohibited. So this shows some figures. So this is some study use our laboratory use this mocking to study the liver disease. This is show the mocking suffer from the distress. Sometimes also suffer from the pain in laboratory. So there is a many association, and they are against the animal study in biomedical research. I give you some famous people. They are against animals. They are against animal study. They are famous in the world. Some people against animal study in biomedical research. Why scientists use biomedical? Why scientists use animal in biomedical research? We discussed several times. Here also gives some idea why use animal study in biomedicine. Because biomedical research needed to understand the health problems before they can develop the means to treatment. Some disease and health problem involve the process that only be studied in living organism. In vitro study is not good for this kind of study. The animals are necessary to the medical research when it is impractical, unicycle to use human being. Human volunteer cannot be used in animals, used in biomedical research. So the animals segregate the human being. The last one is the alternative method for animals that are inefficient. If the alternative method is inefficient, is sufficient, we cannot use animal study. But the alternative method for the animal are not efficient. So we have to do animal study for biomedicine research. Peter Singer. Peter Singer is a professor of the philosophy in Princeton University of America. This is a very famous philosophy about animal study. He published a book, Animal Liberations, a very famous book. The most people reading the book, Animal Liberations. In this book, he popularizing the term speciesism. Speciesism, the word not first given by Peter Libby, but some people in the world know the speciesism. The word come from the Peter Singer, from the Animal Liberations. So in this book, there are some Peter Singer found some difference. Use a human being as you use animal study in biomedical research. They are different. So Peter Singer argue in favor of the vegetarianism and against animal studies. So this is a very famous professor, very famous philosopher in the world. Peter Singer give us a suggestion. When we do if we do some research, we should incur consideration for all means animal and human beings. Equal consideration in human and non-human. That means equal. This means when we do some study use human beings. When we do some study use animals. So we should think, give them equal consideration. This is Peter Singer's suggestions. This slide shows some background of the. This slide shows some background of the animal right movement. Some people at first they think we should give animal protection because animals suffer from distress. So we should give animal protection. When we give animal protection, we think all animals, include laboratory animal, have welfare. Some people think go ahead. Animal have welfare, and animal should have right. So if animal have right, we do not right to study use animals. So they think we give animal liberations. So this shows some background of animal right used in biomedical research. Can we apply the concert animal right to animal? I think it cannot. Why? The first concert right means contract human society. So human society and the animal society, there is a difference. There is a contract. Therefore, we give consent to everyone have right. However, animals never accept others' right. The second, we have fulfilled our obligation and responsibility. If we have right, we have fulfilled our obligation and responsibility. However, every animals never feel their obligation and responsibility. So I think there is the animal. I don't think about animal right. So animal, the principle in nature in one animal is food chain. So we cannot give a concept the right to animal. So this is my opinion. Maybe something is not so correct. Argue that the animal study is right or wrong means that we take priority to progress by medicine or accept animal right rather than human life. Do animals have right? We discuss again. Right is a valid, consisting, mutual right. We have to take responsibility in exercising our right. Keep ecosystem would be difficult if each animal insists right. Companion animal and wild animal would not be equal if we would accept animal right. So, from my opinion, apply a consent right to animal is inappropriate. So I think animal not right. So this is the last one. I will introduce about the animal laboratory animal management administration about animal. So even though apply a concept right to animal is inappropriate, we should consult animal welfare in biomedical research. This is a general suggestion. This is a general overview, general suggestion about the animal study in biomedicine. So we should consider animal welfare. What is animal welfare? Animal welfare is well-being animals. Well-being animals. We should provide good animal welfare is sometimes defined by listing position condition which should be provided to animal. And this is approach is taken by five freedom and the 3 principles of Professor John Webster. John Webster is an emeritus professor at University of Bristol in England. He is very famous in the area of the study of animal welfare. What is free? What is free? Five freedom. Five freedom it means animal freedom from hunger and thirst, freedom from physical discomfort and pain, freedom from injury and disease, freedom from fear and distress, freedom from the comfort to insatiable behavior and punishments. This is the guidance. The freedom were accepted by the OIE's work on animal welfare of the terrestrial animals, including for the finding. So, OIE, do you know OIE? OIE is the World Organization of the Animal Health. It's the same famous as the WHO. WH means World Health of the Organization. This is the World Organization for Animal Health. The French is the OIE. So this OIE is also famous. For example, the World Veterinary Association policy statement for animal well-being and ecology is also suggest five freedom. So the standard of the good animal welfare means five freedoms. This is the content of the animal welfare for the all animals. Animal welfare, five freedoms to every animal is okay. One animal, they live in the wild. So we have respect of the rule of the food till, and do not interfere their sexual. So five freedom is not fit to wild animal. Companion animals, I think animal welfare, five freedom is acceptable. Animal user, five freedom is acceptable. For animal, for laboratory animal, for economic animal, sometimes is okay, sometimes not okay. We will discuss next. The next 3 persons of the three principles from the Professor John Webster. John Webster defined animal welfare by developing the 3 positive conditions. The one is living a nature life. The second, being fit and health. And the third is be happy. I think it's similar. The content of the welfare is similar as the 5 freedom. So this is shows the different view. For example, purpose of the animal welfare. Then we think we should respect animal life, well-being, in living. A purpose for the animal study in biomedical research, we have human and animal health at the progress in medical science. Elucidation the nature of life and the mechanism of the spatial vital process. So from different position, from different perspective, the purpose may be different. So I think each different purpose is right if we argue independent. When we do some study use animal, what we should do? Some scientists give us suggestion. For example, Professor Ross approach publication a book, The Principle of Human Experimental Technician. In this book, they give us 3 R's principle. 3 R's. The first R means reduction. Reduction animal numbers used in biomedical research. The second, replacement. Replacement animal experimentation. 2, invertebrate on experiment without animals. The last one, the third I means refinement of treatment, including care and the environment to reduce pain and stress. This is 3 R's. So 3 R's means the fundamental rules use animal in research in Western countries, include China, because we animal study will want to publication in the world. So we should comply. We should comply with the fundamental rulers of the world. There is a legal requirements about animal studies. In American countries, legal requirement exists for a person involved in animal studies. So scientists who are responsibility for design the animal study must have graduated in one of biomedical science and must, in addition, have taken a course on laboratory animal science. So the people who want to perform animal study must be trained by the laboratory animal science. So this is some show some laws about original about animal welfare or legislation in Europe. For example, 200 years ago, the first Marine Act enacted first in England for the cruel treatment and the Carter Act, and then lost. This is the current law about animal study in Europe. Is Euro Directive to 2010 16.7 EU. This is a current used legislation in Europe. This slide shows the Animal Welfare Act in United States. The Federal Animal Welfare Act is very famous. Sometimes is very famous. Also, is a key law governing research with animals. So this act, Animal Welfare Act, regulated use of dog, cat, primates, guinea pigs, hamster, rabbits, farm animals, but rat, mouse, birds excluded from the animal welfare in the United States. The law required all proposals use animal study must be reviewed and approved by Atiq. What is Atiq? Next will show you. Requires animals to be provided with adequate food, living spacing, veterinary addition. Dog must be received appropriate exercise. Primate must be provided environment that will ensure the cycle well-being. These are other actors, for example, the health research extension actor require all medical research funded through the NIH to conform the public health policy of human care and use laboratories. This is some laws. There is a book, a published book from the NIH, and most other funded the published book. The book name is the guide for the care and use the care and use of laboratory animal. Then in this book, summarize all the law about how study animal study in biomedicine. So this is when we do some animal study, sometime we can look this guide for the care and use of laboratory. I'm sorry, compulsory training. I just show you when we do some study, you have two training. You have to training about how to perform animal study. You have to get some knowledge about the animal study, laboratory animal science. This is a compulsory training. What is IACUC? IACUC means Institutional Animal Care and Use Committee. So when you do some study, your proposal must be approved by IACUC. This is sure IACUC members, for example, at least a doctor, veterinary, and scientist, the public members. All animal protocol were approved by should approved by 西安交通 University Animal Experimentation Committee and perform under the 西安交通 University guideline for animal experimentation. When you perform animal study, so your proposal must be approved by 西安交通 University IACUC and performed under the 西安交通 University guideline. This is give some sample about PLOS journal. There is many journals of PLOS 1, PLOS medicine, PLOS pathology, PLOS other journals. For this give sample when you submit manuscript to the PLOS journals, you should write the same sentence. For example, the protocol was approved by the Committee of Insects Animal Experiment of the University of Minnesota, for example. This is a sample. So animal studies, when you submit a manuscript to PLOS journal, you have to give the journal about the permit number. This is the next slide shows some current progress in animal welfare. For example, environment enrichment. This slide shows environment enrichment goals. For example, improved quality of the captive environment, increase behavioral diversity, reduce frequency of the of abnormal behaviors, increase positive utilization of the environmental, increase an animal's ability to cope with challenges. This is the mission of the environment reach. For example, we give some we put some tours for animal cage. We can provide some materials for animal hiding. So this is the sample environment enrichment. For example, mouse can climb ladders, make a nest, dry calves. This is also a sample shows the environmental enrichment. This also shows, for example, rabbit like him instead of a plant diet. So we should give the rabbit him. The last important is about human endpoint. Human endpoint I choose minimize or treat terminate the pain or distress of the animal when euthanasia rather than waiting for their death at the endpoint. That means animal suffer from the distress. We should euthanasia animal and not wait the animal death at the endpoint. This means human endpoint. This shows the general human endpoint. For example, the body weight loss of 20%, the animal should be euthanasia. This is show the slide shows some sample. The animal should be perform euthanasia. For example, want to do some research, human germ cell line was transplanted to immunodeficient mouse. The tumor size is very important. If tumor size is large, is too large, the animal may be suffer from the severe distress. So the tumor size is not so large. For example, the American Dr. Fellow publication, journal publication, their research work in Nature, very famous journal in the world. But the mouse tumor is very large. So some people against, they were against the animal studies. They suggest the people should be the people should be withdraw the people. At first, the Nature journal withdraw the figure, and last the all people were withdrawn. So, and this is another sample from our university. The scientist, the very famous professor, come back from America. He publication their research works in a very famous journal. The journal is very good. The publication, after the publication, their result, the citation is over 13. So I think the work is very good, but the publication were retracted. Why? The author said the author said the approved from the Animal Ethics Committee at Xi'an University was not received prior to perform the animal study, although it was stated as such in people. The author applies for the oversight, so they have to retracted the publication. Summary about ethics about animal management. So we should give the good environment environmental. So we should let animal feel that happy. If the animal happy, that means animal have a good welfare. If the laboratory animal have a good welfare, means this is a good science, good laboratory animal experimentation, the good biomedical research. This shows also New England Journal of Medicine, very famous in the general medicine area. For example, they refuse to publish UNESCO work. So this is for example, when you do some research, you do not think about animal welfare. your research work cannot publication. For example, in New England Journal of Medicine. This study shows the Gandhi, very famous in India, very famous in the world. The praises. He said, the greatness of the nation and its moral progress can be judged by the way its animals are treated. So it's very famous. It shows a greatness of the nation. They should every people in this nation, the greatness of nation, they should think about animal welfare. We should give animal welfare. So the last slide, we give you some new suggestion. You think about when you learn, when you study today. When you do some study, use the mouse. You should use inboard mouse. C57BL6. The mouse is your first choice. If you do some study, animal study, use rat. Anti-brand SD-DOS is suggested. GM element, genetic modified element, the king animal models used by medical research. So you do some research, use animal species, and first you should think about the transgenic or lockout or conditional lockout mouse model is very important. Rodents, all rodents, include the mouse and the rat, should use SPF. SPF means specific passage frame, and this mouse should be kept in burial system, burial facility. All animal protocols should be approved by RACUC. And the last one, when you do animal study, you have to respect 3Rs, and animal welfare. That's all. Let's all. If you have some suggestion, if you have some question, you can tell me or send a message. That's all. Thank you very much. Thank you all from the different countries all over the world. Thank you, international internet. We can meet here. I can share my thing to you. Thank you. If you have a question, if you have a suggestion, you can call me. Any question?
Hello, sir.
Hi.
Sir, this is Zishan. Sir, it's a request. Like, can you show us your WeChat? Like, can we join you in WeChat?
WeChat.
Yeah, Vision. Is it okay?
Okay.
Then can you like show the QR code so that we can join Vision?
Join Vision.
WeChat.
WeChat. Yes, I see. Okay.
What about this PPT? Today's lecture's PPT. Can you send the PPT for us so that we can see this PPT after class?
Yes. I can see. I can see the PPT to you. The secretary. Yes, we will send it to you the PPT in our group, in our WeChat group. Okay.
Okay. Thanks a lot, Professor.